shape of an open right circular cone, as shown in the figure. The height of the container is 10 centimeters, and the diameter of the opening is 10 centimeters. Water in the container is evaporating, so that its depth, H, is changing at a constant rate of -3 over 10 centimeters per hour. Some things to keep track of would be the diameter of the cone and the height of the cone, as well as the volume equation of the cone, which is 1/3 pi r squared times h. Okay, so our first part of our FRQ says find the volume V of water in the container when h equals 5 centimeters. Indicate units of measure. So starting off with problem A, what we need would be our volume equation for our cone, and then we have some of our given, like h or height equals 10 and diameter equals 10, and so with the ratio, there's like a ratio you can see here, so we can call it like a height to diameter ratio, which is 10 over 10 or 1. So in this case we can assume that at h equals 5, we can also assume that diameter at h equals 5 centimeters. Okay, well, let's get started. First we have to figure out our r. So r is our radius, okay? And we know that diameter divided by 2 equals radius. So our diameter at h equals 5 centimeters is 5 centimeters divided by 2. And in this case, that would be our r for when h equals 5. Now, hold up, divide that up real quick. So, now from here on, all we have to do is just plug everything in like so. Velocity equals 1/3 pi, and our radius 5 centimeters squared, or divided by 2 squared, times h, which is 5 centimeters. So let's do this one real quick. This would be I'm gonna just bring up the pi right here, times, that's 25 right there, so that'd be 25 centimeters squared over 4. And I'm gonna turn this 5 centimeters into a fraction to less work, basically. So it'd be 5 centimeters over 1. And then from here on, you multiply all the way across. So we have our 12 for our denominator. 3 times 4 times 1 is 12. Let's do this here. And then we have our 25 centimeters squared times 5. And that's 125. And we cannot forget our units. We have centimeters squared here and centimeters. When we're multiplying centimeters squared with centimeters, we get centimeters third, and don't forget our pi. And there you go, there's our volume.
So for B, the prompt says find the rate of change of the volume of water in the container with respect to time when h equals 5 centimeters. Indicate units of measure. So we're going to find the rate of change of volume, which is dV dt. And our given is h equals 5 centimeters, and then the h dt, which is given in the original prompt, is -3 over 10 centimeters per hour. And then for the whole cone, we have r over h equals 5 centimeters to 10 centimeters. So r is going to equal 1/2 centimeters. It'll make it easier to plug in our equation. So when we're going to plug in our equation for volume. So we have v equals 1/3 pi, and then r, which equals 1/2 height, or h squared. We're going to do 1/4 h squared, because 1/2 squared is 1/4 times h, and this could simplify to 12 pi h to the third. And then we have to find the derivative, which is dv dt, and we'd get 1/4 pi h squared dh dt. And we know what dh dt is, and we know what h is from up here. So we'll have 1/4 pi, and we can't forget our units, so it's 25 centimeters because 5 squared is 25, and then -3/10 centimeters over hour, and our final answer is going to be -15/8 centimeters to the third hour. That is our answer.
For C, it tells us to show that the rate of change of the volume of water in the container due to evaporation is directly proportional to the exposed surface area of the water. What is the constant of proportionality? For question C, it's asking us to prove that dV/dt, which is the rate of change of volume of water, is directly proportional to the exposed area of the water, which is this circle right here. So we know that the equation for area of a circle is pi r squared. So to make sure or to prove that dV/dt is equal to the exposed area of water, we can write dV over dt is equal to the constant. So we know that it's going to be our k, pi r squared, which is, again, the area of the circle. So we can start plugging in our values, and we know dV/dt is equal to -75 pi over 40 or -15 pi over 8. So -15 pi over 8 is equal to k, which we're trying to find, pi, and then our r. We know that r is equal to 1/2 h, and we know that our h is 5. So we can say that r is equal to 5 over 2. So 5 over 2 squared. So we can distribute this exponent. So it'll be -15 pi over 8 is equal to k pi times 25 over 4. From here, we can bring this pi over here. So -15 pi over 8 is equal to k 25 pi over 4. Then we divide by 25 pi over 4. Then we have -15 pi over 8 times the reciprocal, which is 4 over 25 pi, is equal to our k. So from here, you can do multiplication. These pi's cancel out, and you're left with -3 over 10. You will not need any units. This video was made possible by assignments like these. Thank you.